It then. So thanks everyone for joining the session on Sagemaker series. So for those of you who are kind of new or don't know what Sagemaker is, a brief introduction is basically Sagemaker is basically a managed ML platform on AWS, right? So essentially, it lets you do machine learning at production level machine learning, right? There's a very big difference between machine learning on your laptop and production level or cloud level machine learning, right? So SageMaker is, I would say, a clear market leader in terms of the machine learning capabilities um, in the across all the different products, right? So they have extremely high feature-rich offering, which means you can do a whole bunch of things. You can build basically, production level, petabyte level, terabyte level, whatnot. That sort of processing, and at the same time drill down to the most important artifacts and key things that you want to look at when you're doing your machine learning jobs, right? So essentially, that's the use case. So basically, it's for productionizing your machine learning jobs and pipelines, etc. And now, as a part of the so-called machine learning pipelines, there's a bunch of steps that are involved, right? So essentially, if you've ever done any data science project, it typically starts with data collection, then data processing, then data like cleaning, and then there's exploration, then there's feature engineering, then model building, fine tuning, and finally prediction/deployment, right? So these are the typical features, steps involved in a machine learning pipeline. Now there's some more uh, like steps that come after the process and in between the process, but we're not going to go them. Things like explainability and feature, of feature importance and data drift. There's a whole bunch of other things that are important as a part of building production level machine learning, but we're not going to touch right now. We'll be covering them in the future sessions, right? So today's session is essentially focused on feature transformation. Basically, how we do this in a production setting, right? This is again, the key word is always big difference between production level machine learning and your laptop level machine learning, right? So now with that introduction, let's get into the actual session. So this session will roughly run for like 45 minutes or so, and we will cover many different topics in this session. And if you feel like you're getting lost somewhere, you want something to be explained a little bit more, feel free to stop me and ask me for any of the questions, right? So with that said, let's get started. So what is feature transformation? Okay. For those of you who don't know what feature transformation is, basically, essentially, uh, you know, we're converting the given raw data into useful mathematical representation, which a machine learning model can use. Ultimately, machine learning at the core of it is nothing but it's done by a computer, and computers only understand numbers, right? We don't understand like images or text or audio, etc. So all of those other signals which are human interpretable, we have to convert them to numbers, right? So that is the process. The process is called feature transformation. Now, this is actually one of the most important parts of machine learning, even that get a lot of spotlight, right? So the most spotlight comes to the models, like for example, ChatGPT, or we have CNN models, et cetera, for image transformation. But the feature transformation, the step behind the actual model building is extremely important, because this can literally make or break the whole pipeline, right? That's why you need to pay a lot of attention to this, to feature transformation part. Now, in this particular use case, what we are looking into is basically we're trying to convert raw text. Okay, so let's say you got some sort of reviews on on Amazon, or somebody writes a tweet. So how you take the tweet and then you want to do sentiment classification, right? So how do you do that? So before you do that, you have to actually convert the text to features, correct? So this whole session is just about that. and how we do that as a production level, right? So in this given example, we have a bunch of text from Amazon reviews, right? So, and then there's a rating. Okay, the idea is given a bunch of basically reviews, will you be able to predict the rating, without actually knowing the rating, right? Obviously, that's this. So there's the concept of test and train. So and then validation. So how many here know what test, train, and validation is?
Yeah, I know it.
Yeah. So can you explain us what you know test, train, and validation?
Yeah, for training, we are just we split the data set usually into training, validation, and test set. So in training case, we just train the data on, and while we're training, and if we have to do the parameter tuning, we would check the results from validation set, and later on, when our model is trained and we want to test it on the wild, we just go with the test set and see how the performance is.
Perfect. I think you got it. You nailed it, right? So essentially, exactly, it's that, right? So train, validation, and test. So you train your model initially on the train set, and then you do your hyperparameter tuning on the validation, and then you test. You use the test set just for testing, and basically publishing the accuracy of your model, right? Now, so that's the whole process of splitting the data set, right? Now, before we even do that, so essentially what we want to do is something called feature engineering, right? So how we do that is basically we are, so here we've assumed that we'll be using a BERT model. Okay. Now, when we want to use a BERT model, essentially what happens is that you have to take the text and convert it to some sort of vectors, right? So prior to BERT, there were other text models like Word2Vec, Doc2Vec, GLOW, etc., which used to convert sentence by sentence, sorry, word by word, right? Whereas BERT has this bidirectional encoding that goes from right to left and left to right, and it has a sense of sentence as well, right? Not just a word. So, for example, if you pick a sentence like "This is a great item," it matters whether the grade comes first and item come later, etc. Right? Because that's how the English language flows. So essentially, there is a sense of position as well, and that's what gives the incredible accuracy that comes with BERT models. And now BERT models are pretty much the state of the cutting edge models, basically, right? Now, so as you can see here, we're converting the star rating to a label ID. Okay, if you noticed, 1 has become 0 and 5 has become 4, etc. And the reason is that we are using a NumPy standard, right? So that what happens is start from 0 and etc. etc. At the same time, basically we're converting the text into vocabulary, right? So BERT vocabulary. So in BERT, there are 3 things. First thing is input IDs, right? It's not shown here, but I'll just scroll down a little bit and show you that. Give me 1 minute, guys. Sorry about that. Yeah, so there's an input ID, input mask, and segment ID. Okay. And then there's the label ID, right? Label ID is basically what is the classification? That's easy. So what is input ID? Input ID is basically you take a word and then you will try to get a token for that in the BERT hyperspace, right? So then there's an input mask and segment ID. So segment ID is something that essentially will be used for like a question answering thing. So for example, you have a question answer, right? Segment ID will be used to identify that. So for example, you're giving a question and answer, okay? So question will get segment ID of 0 and answer will get a question segment ID of 1. That will be differentiating between two pieces of text itself, right? Whereas in the classification, there's no such thing. There's only segment is going to be 0 because there's only one piece of text we're passing. Input mask is basically it gives you a certain sense of where this keyword is, right? So is it first, second, third, etc., etc. Okay. Apart from that, there are other one more important thing you have to know about BERT, which is basically the maximum token count, right? That is something we'll cover slightly later, but that's also very important as part of our training, building a model, right? Now let's walk through the code quickly. This code is basically created by there's a book called Data Science on AWS. This code comes as a affiliate with that. So I've modified the code so that to make sure it's easy to run, and I've done it. I've done the fine tuning, etc. I'll also download this code and put it on GitHub. So if you want to refer, it'll be below the video on YouTube, so you can refer that later, and you can run it very easily. And if you face any issues, please comment in the YouTube videos so that I can respond to those comments. Okay. So somebody has raised the hand. So I think Vishwa has. Yeah, TG, what is the question?
Krishna, I just want to understand, like when you're saying that the processing of the text is the consist of only text elements, or is the combination of different type of stuff like image and
No.
or special symbols, something like that?
So basically, in this particular use case, the use case is we are just looking at some sort of, basically rating prediction. Okay. So for example, let's say somebody gives a rating and then they give a, somebody writes a text and then they also give a rating. So we are trying to build a machine learning model that can automatically predict the rating. You get me? So for example, let's say somebody says, hey, this product is very bad. What is the rating they should get? They should get 0. Okay. 1, right? Let's say they have a rating of 5. Okay. That should come to something, a text like, hey, this is wonderful, right? So we are trying to teach the machine basically how to get that. Does that make sense?
Yep, Krishna, got it.
Yeah. So there's not going to be any images or anything because it's purely a text classification, multi-class classification problem. Okay. Right. All right. Let's get started with the code. Let's speed things up a little bit. Yeah. Now, so essentially, this is one of processing jobs that we are writing in SageMaker, and SageMaker, like I said, is a platform created by AWS, right? So so you start with the imports. Okay, so you have something like import SageMaker and import Boto3. Then you have to get the current session. You got to get the role. You get the default bucket and then region, etc. So all of these variables are useful at a later point of time. That's why we are getting them now. And then we want to get the data. So there is a magic function called store. This actually stores in the way it persists any variables that you put in this particular kernel, right? So this is a SageMaker Studio. This is basically a window in a SageMaker Studio, right? So this is like a notebook in SageMaker Studio, and let's say you store something in this session that can be referred back later in a different notebook, and that's the idea here, right? Because we are using this for just feature processing to later when we use for let's say a training, we can actually get these variables directly. And this is extremely handy, as you can understand, right? So here, this is basically this is the data that is provided by Amazon for for training and tutorials, etc. Now, what we are doing is we are pushing this data. We are creating a private path. Now we are going to eventually push the data there. All right. So this is already pushed. That's why we're not doing it again here. And if you go and check this particular URL, you're going to see these 3 different ZZ files, right? So they're TSV format compressed files. So we're going to uncompress these files, get the text, and then convert that to a BERT feature encoding. That is the whole point of this exercise. It looks like a simple function, right? Technically, it is a simple function. This is basically one function you write to do this. But essentially, because we want to do this in SageMaker on a production level, we have to run a bunch of code that makes sure that connects with the databases and gets it properly and all that, right? It's that. Okay. Now, so this is the actual script, the script that converts the text into BERT encoders. Okay. Now, I'm not going to go through this script in detail because this is already something I'm going to share on GitHub. You can check it out later. But essentially, this is it's a script that actually converts the text. If you pass text, it will convert to a basically BERT encoding, right? Now that part is clear, but there's a whole bunch of other things that we need to do that, right? The first thing is, as you can see, we're using something called distill BERT and not using BERT itself, because distill BERT is a much smaller model compared to BERT, and it's as good as the larger BERT, okay? And there's a then we're defining a bunch of things here. I'm not going to, like I said, I'm not going to explain too much here. Some parts of this are explained in the code as well, so we'll get to that later. Okay. Now, so basically, as you can see here, these are all the things that we are going to come up with. Given a text, we want to get this input ID, segment ID, input marks, etc. Okay. Okay, let's skip this thing. You guys can go through this later at your own time. Now, just think of this way. This is a script. Okay, this is a Python script that we're going to use in a processing job. The important part is how the processing job works. That's what is the session about. Okay. Now, so as a part of processing, there are a few things that are important to understand from a point of view of building a machine learning project on SageMaker. There is a concept of experiment. Okay. So what is an experiment? Experiment is like a module where you run a bunch of pipelines and you can tie them together so that you can actually group them together and say, hey, this is the experiment that I have run. These are all the pieces of the experiment. Okay. This is very useful if you're basically running a production environment, because then you would know, hey, which are the pieces that fit into that particular grouping. Okay. And there is a concept of trail. There's a trail component and there's a tracker. This is very nicely explained here. Okay. So as you know, the way a typical machine learning works is that you build a model, you fine tune the model, right? Then you do fine tuning again and again and again, right? So first you do one trial for that, and then second trial, third trial, etc. As you can see here, so those are called trials. Okay, and then experiment is basically the superset. So all of this hyperparameter tuning can come into one experiment. Okay, now you can say we can create multiple experiments also. That is also possible. But let's just say I'm working for 1 week on a particular model. I'm going to classify all the models that I do in 1 week under that experiment, because that will be easy to refer for me later. Okay. So experiment is a super hierarchy. Then comes trial. Then there's a trial component. Okay. And there's a tracker. This is how the hierarchy works. All right. So essentially you have experiment, then trial, then the trial component. So for example, you're doing feature engineering. That's a trial component. Then there's something like training. And then there's something else, right? All of this will come as all the pieces of puzzle can be called a child component. This is a tracker. And what's the reason for tracker? So tracker is basically going to give you information of each of the steps. It's like a logging, right? So once you have a logger, you can see, hey, what is the time taken for this step? Has this worked properly? Has it failed in any of the times? How many files have happened? All of this information will be included, so you can actually drill down to that level. That's the whole point of Sagemaker. So the point of Sagemaker is, hey, you're not going to give any minute detail to chance. You're going to log everything and record everything, then visualize things, important things. That's the point of Sagemaker. I hope you guys appreciate the difference between writing a machine learning job on a Jupyter notebook in your laptop and doing something on Sagemaker. Yeah. Is it making sense, guys?
Yeah, definitely. I have a question, Krishna. So like if you scroll up a little bit, when we see the diagrams, so in trial A, we first prepare it and we train it. And then in trial B, we train it again. And in trial C, we train it again. Why not extend the training from trial A right away?
I think, yeah, so you kind of confused there. So basically, training is the trial. All right. So I built a model. I'm training once, I'm training again. But to answer your question, I am actually reusing the features, right? Features I'm not building again and again. But training I have to do multiple times, right? That's the whole point of, basically experimenting is I have to train multiple times. Okay. So there's a trial A, which whose set is a feature set. There's a feature processing step and there's a training step. These two come under trial A. Whereas in trial B, I don't have to use the same feature process. I can use the same feature processing from the previous trial, but the training is new, isn't it? Yeah, I hope that makes sense. Yeah.
When you say features, do you mean weights of the model or do you mean the training data?
The feature process data. The weights of the model, I'm not going to use the same thing, man. See, I might use a similar thing. So to do like a jump start or whatever, right? Warm start. Not so that model tuning is the main thing here, right? Feature processing, you do it once and then you can use the same feature process features multiple times. But model training is the main job here. We have to do it multiple times. Uh, anyway, let's go forward, yeah, because there's a lot of things to cover. Okay, so like I said, so this experiment is super umbrella, and then below comes trial components and tracking, etc. So we are basically initiating all of this, right? As you can see here, I'm writing a. So the key point is how you write this. Okay, so as you can see here, you can put a name for this experiment, and then you can put a timestamp, right? So using the current timestamp, you are creating the name, and it's very good practice to use a timestamp at the end of a experiment name, because then it gives you a sense of when it happened. Okay, when the code first ran and when did you do this and all that, right? So that's very important that way. Same thing for trial, right? So you can also put a timestamp. So it's a very good practice to put timestamps wherever possible, because then you can just by checking the name itself, you can see, hey, what is it, where is the reference, etc. All right. So then you're setting up the experiment through experiment config, and you're persisting all of this. So when I say persisting, you're storing this into basically the Amazon Studio, right? So this Amazon SageMaker Studio has a concept of elastic file storage. Okay, so whatever you store here will be sent to all the other notebooks on this session. Okay, for this particular user and for this particular session. In fact, there's a concept of domain. Then you can even share this persisted information and variables to other users as well, right? We'll get to that later. We'll cover the concept of SageMaker domain a little bit later. Okay. So then comes the important thing called feature store. Okay, what is a feature store and feature groups? So basically, the concept of feature store is once we create features from the raw data, right? And I told you that we're going to use the same features again and again. So the feature store and feature group concept is you store this in a centralized repository so that you can refer from that easily. Yeah, instead of leaving it somewhere or putting in some random location, Amazon SageMaker has a provision to store these features tagged under an experiment, right? So there's an experiment and there's a feature store. So there's a tagging there. So you can now put all the features there. That's why you can refer later, right? So these are all nuanced details, nuanced features that help you in the long run. This is how productionizing machine learning is. All right. Okay. So then you have a feature group. You're going to define your features, right? Ultimately, I'm going to take my text and convert into these features, right? The first one I explained you: input ID, input mask, segment ID, label ID. Then there's a review ID. For every review, there'll be a review ID, unique review ID. Then there's a date and label. Okay. So these are the important features I want to keep in my feature store. I might use in the future, so I want to keep in there, right? That's the point here. Okay. Now comes the important part. Okay. Hyperparameters, right? So basically, for the processing itself, there are hyperparameters or parameters. Actually, in this particular case, they're probably not hyperparameters, strictly speaking, but like they're parameters. So the first one here is processing instance type. Okay, what is the instance that you're going to use, right? So the instance here I'm using is ml.c5.2x large. Okay, so ML stands for machine learning. C is a class. Okay, it's a compute optimized class. 5 is like the version number. So the latest for this is roughly 5. So we used to have 4 and 3 back in the day. Now you're recommended to use 5. And then X large is how many CPUs do you need, right? Is it like 1 CPU, then 2X large, then 4X and 8X and 16X, etc. Similarly, this is a nomenclature of an instance, right? There are instances where compute optimized is there. There's like a memory optimized. Then there's like a GPU thing that you can use for actual training jobs, right? Because training involves a lot of computations, etc. Then there are multiple types. So there is high performance computing optimized one. There's a whole bunch of different computational instance types that Amazon offers, which are purpose built. All right. So you pick and choose based on what you want. But you have to actually there'll be quotas on each of these things that you can use. I'm going to show you what a quota looks like. This is very, very important, so I'm telling you. So I've spent a whole bunch of time, requesting quotas from the Amazon guys. So, okay, so this is called service quota. Can you see this, guys?
Yes.
Okay, perfect. So in service quotas, Amazon has extremely strict quotas, right? So there is so every instance also has a specific function. Okay, so you can use this instance for this function and they have a quota for that. Okay, so you can see this MLC5 2x large. I can only use it 2 instance types, right? So I can't use any of the other processing instance types. So for every job, they have a different instance type, which makes your life complicated. But ultimately, it's a security protocol so that you have this discipline of using a particular instance type for a particular job, and you're not, doing random things. You're not doing anything and everything. Okay. So this is a very useful feature that we are providing, but it makes the life of a developer a little bit harder. Okay. Anyways, so like I said, we're going to go back to this. Then we are doing a train split percentage, right? So we are using this percentages to split the data into train validation instead. So what we are doing is, so I'm taking 90% of the samples for training, 5% for validation, and 5% testing. Okay. So then there is the last one, which is very, very important, max sequence length. Okay. So what this means is basically when you're building a BERT model, right? Ultimately, what do you have? You have all this text, okay? And text you're converting into numbers, correct? So how big do you want to take your text as? Like, what is the text size you're saying? How big do you want the vector be? So when you say 64, your vector that you're going to feed in for every review is going to be of that size, right? That's the maximum you're saying. Okay. Usually most of the reviews are below that, so you don't have a problem. So once you have above that, there's a problem. And what you do is basically you split the text into 2 vectors and then go and run. Yeah, does it make sense?
Yes.
Okay, let's look at this, right? So what we are saying is, hey, there's a whole bunch of reviews whose word count is not more than, let's say, 5 or something, right? You have maximum here. So there's another peak here, but at 64, I'm covering almost 90% of the samples, right? So there's only 10% I don't have to bother. So see, I can't put like, if I take 128, then the problem is I'll have sparsity for a lot of vectors, right? It's too much sparsity. This means training will be much harder. There's a memory constraint, etc. So I have to take a balance, right? So this particular chart histogram is very useful to decide this number. So based on this number, what I'm saying is, yeah, I'm okay with this. I'm going to go with 64 because almost 85% of 80% of my text is covering under this. So for the rest 20%, I'm going to split it and use it in a second vector and third vector, etc. That's the trade-off I'm taking here. Okay. Now, so let's get into actual processing. So basically, I'm using a sklearn processor here. This is a definition of a processor. Here I have a processor instant type and processor instant count. These two we have already defined here. Okay. So we're instantiating them here. Basically, we're creating a processor object, right? And then we are actually supplying hyperparameters. Sorry, we are supplying parameters and then running it. All right. So this is the crux of the pipeline, guys. So please pay attention. And if you have any further questions, etc., just hold on for now, right? So this is the input, commands, right? So we are saying input name, source, etc., etc. Then outputs, we're defining outputs here. Then we're supplying a bunch of arguments, right? Train split percentage, validation split percentage, etc., etc. Now, the way why you want to declare this way is that you can actually send these parameters in runtime. Okay, that is a powerful thing. All right. So that is what is very powerful. Now, for this piece of code, these will be sent as arguments. That Python code, which actually splits the text into BERT vectors, takes these parameters at runtime as arguments. And that is the crux of it. The whole machine learning pipeline building process is mainly about arguments and sending them runtime arguments and runtime, like using those args and all, right? Python args, you know. So that's the whole thing. This is the most important thing. So what are the arguments I'm sending here? That's what you need to pay attention, right? Train split percentage, validation split percentage, test max sequence length, balanced data set. Is it a balanced or imbalanced one, right? Balanced or imbalanced means what? So basically, like when you have reviews, is it distributed reasonably uniformly, or is it just like one review 99% on one rating and like 1% on others? That's an imbalanced set, right? If it's an imbalanced set, you have a slightly different treatment. Okay, so then you have feature group name and all that. So all of these I'm sending as an argument. All right, now I'm running this job. Okay, so I'm running this processing job. Basically, this is it basically. So this is the crux of the this whole session, right? We finally come here. Okay, now like when I'm running this job, so there's a job ID also, so I can actually go and check how this job is running. Obviously this job is already run by me, so it's not going to run again. Okay, but you can see what happened, what is the logging, what is the status, etc. This is the again a very, very useful thing, because this gives you clear logging with timestamps, etc., to see how the job went through, how much time did it take, what are the steps involved, so how many failures were there, what are the compute it consumed, what is the volume it computes, everything is there. All right, you can see that here, right? Any questions so far? So you can see that all the different parameters that you sent right previously, they're all coming out here. You can see that, right? So where is the output, input, everything is coming out and then nicely in the logging. And that is why we have to define parameters in the way Sagemaker suggests. So whatever Sagemaker is giving you, like you have to define in that way so that you get this nice representation. Okay, that's very important again. So if you follow the nomenclature of the recommendations of Sagemaker, when you run a job, you'll get all these logs and metrics so that you know what is happening behind the scenes. Okay, and with this you can actually do debugging and see, hey, what happened, how it happened, etc., etc., right? Then the last thing is you can also check logs, like actual raw logs on CloudWatch, right? How many of you have used CloudWatch before?
Me, but for like not for AI, for
Yeah.
APIs and logs and all.
Yeah. So if you've used it, you know, right? You know the power of CloudWatch, right? It basically gives you logs on a like for every event level. So here
Definitely.
you can, yeah. So all of these things are integrated. So you can actually check out all the logs that are being written. So you can see that file, the processing file that we have actually used. So it's basically starting with that, and it's like collecting all the libraries, etc., right? Just to be clear, so I mean we'll do a small other session on the behind the scenes of SageMaker, right? So how this whole processing works, how are the instances created, what do we mean by like what is the point in using a particular instance and library, etc. So all of that we will cover in the next session, more like a behind the scenes session, right? There you will understand how the containerization happens. So ultimately, all the things in SageMaker are basically containers, right? So everything is run in a form of a container, right? So once you understand how that works, you can actually tweak that and then build your own container. You can bring your own container. You can use some features from a SageMaker, and some features not available. Then you can bring your own features also, right? So that is the whole point of understanding the behind the scenes, right? So we'll discuss that a little bit later because we have too much to cover. Uh, so now moving forward, we've already seen the processing job, right? Are any questions on the processing job itself?
So
Okay.
is it like traditional queue jobs? So jobs in a queue and they are being run.
No, there's just one job here, no? So it's just one processing job.
So if I have multiple jobs,
So you have multiple jobs that is being covered under next session called pipeline. Okay, where there's a queue, there's multiple jobs, etc. So in this session, we're only talking about one job, which is basically feature engineering / processing.
okay,
Okay.
perfect. And would this be a good practice before sending to the SageMaker? Should we test the whole code locally the way we do on Jupyter Notebook? Because what if it crashes
Yeah.
later on?
Yeah, that's a good question. So see, basically that processing code that was there, right? That ideally should be developed in a local notebook. Okay. Uh, the other thing is you actually don't have to worry too much, right? So let's say your data is sitting in S3. Okay. If you're going to use locally, then you have to download the data locally and all that, right? Instead, you can use these notebooks right away. So actually, you can completely forget using local Jupyter notebook. That's the advantage of SageMaker. You can do the prototyping and productionizing in the same location. That is a very convenient thing, right? So I would say don't use local Jupyter notebooks anymore because they you have huge memory limitations, and then B, you might lose your code, you might lose your laptop, then the code is gone. C, it's not a good practice because now if you're using you don't have to get, so if you're using SageMaker instead, this code automatically gets saved and it can be shared to your friends and colleagues, etc. easily. So you don't want to do that. Okay.
Just another question regarding SageMaker. So the thing is, at times, SageMaker is mostly focused on, I believe, on GPU and grade processing for machine learning. I have faced, circumstances where the limitation was memory itself because I was generating the data in the real time while training the model. So would SageMaker be able to deal with places where data which has to be loaded for training is so much that it could be more than 100 to 100 GBs? Would SageMaker be a good fit for that?
So SageMaker is like built for those. Okay.
Oh,
With SageMaker, you get production level, meaning you can throw in any amount of data, right? Obviously, you need to know how much data and how many instances you need, what are the optimization for that, right? But again, SageMaker is built for that main use case. The main use case of SageMaker is it can handle any amount of data. It can handle internet level data, right?
oh,
And it can execute jobs at that level with the immense compute power, immense memory optimizations and whatnot, right? So that is a use case for SageMaker basically.
great, thanks.
Yeah. So now that the jobs were done, we can actually go check the data and this data, the feature engineering data is actually written back to S3. So we've taken data from S3 and now we are putting data, the process data back in S3. And why are we doing that? Reason why we do that is basically so it's secure. S3 is a very secure location, right? It's reliable, highly reliable, secure data storage, and it scales to petabytes and whatnot, right? So you can throw in data, any amount of data in S3, and it's very cheap and it persists easily. Okay, so S3 is like your default choice for any of the data operations. So the only problem is the read is not very fast, right? So if you want fast reading, okay, for certain applications, then you don't want to use S3. You want to use other things like Redshift or whatever. But in this particular case, we don't care about that. All we have our goal is to persist it with security and reliability. So S3 is a very good use case for that, right? Now, you see two things here, input and output. Actually, the important thing we're looking for is output, right? So what are we getting in the output? So BERT test, train, and validation, right? So we have taken the data and then we have made 3 splits. Now we are going to check those splits. Let's look at train. Okay. In train, we've got 3 records. And the reason is that there were 3 inputs, right? So for those 3 inputs, we've gotten 3 outputs. Okay. So it is converted to something called a TF record. What is TF record? It's basically a TensorFlow record data type. It's not a CSV. It's not like JSON. It's a binary format which is highly optimized for machine learning jobs. So in this format, it actually stores the data and as well as label, which is very useful because, and it properly segregates them so that what happens is when you take this, you can train very easily. This is a very good feature for training any TensorFlow models, right? This has become industry standard. TF record has become a industry standard for storing and moving data across. Basically, it's called serialization, right? So it's become an industry standard that way. Now let's look at. You can also look at something like monitoring, right? So obviously this job is already finished because I ran it previously. But while the job is running, you can also monitor. When you're monitoring, you get all these other metrics which you can go check out and see what's happening, etc. Right? Now, the last thing is we want to check and see if the data is stored properly, right? I've already shown you manually. This is programmatically. You can see that you got all these outputs. Yeah. For each of the file, there are 3 outputs. We have nice little TF records for each of them. Now, what is inside a TF record? We want to see that. Okay. So we will take a sample one. We'll just process it and we'll see. So what is the one, right? I've just taken one sample from a particular TF record and I'm seeing it. What do I see here? There's a key called input ID, bunch of values, right? Then there is an input mask. Then there is a segment ID and there's a label. These are the 4 things I have in a given record. Okay. Right? So basically it means it's finally working. This is what we want, right? This is what we need in BERT. Now I can take 2 samples instead of 1 sample and I'll see something different, right? Okay. Why is it not running? Oh, this notebook is not working. That's why it's not showing. I have to run the whole thing again, but you get the point, right? So you have all this data basically. It's showing in an NumPy JSON array format. Okay. So and then we are finally persisting all of this data back to the EBS, elastic file storage, basically. Okay. So if you click this, you're going to see all the different variables that have been stored in EBS so that can be shared across all the different notebooks, basically. Okay. So the last thing is experiment analytics, right? Let's quickly finish this because I think we've already spent a lot of time. So basically, there's something called experiment tracking lineage, right? So what happens is here you can have like a trial component names and you can check what are different trial names, all of these other data that you'll get here, right? You can take this data and you can persist it. You can put it in it's already stored in Sagemaker. You can use it for further analysis. Okay. Then it goes a level below, which is basically there's something called lineage graph, artifacts, etc., etc. These things we'll cover in the next session. What are artifacts and etc. We'll cover in the next session. There's something called lineage visualizer. We'll also cover this in the next session. All right. So with that, I think we are done for this session. Thanks a lot, guys. Thanks a lot for your time and effort. Yeah. Thank you.
Hello.
Yeah. Hi.
Yeah. One question. Does Amazon SageMaker also provide anything when it comes to data augmentation, as we might be needing?
Data augmentation is basically how do I say? See, it's a processing, right? It's a mechanism that you have to do by yourself, right?
Okay.
Amazon SageMaker is a platform, so
Perfect.
it doesn't give you like it gives you libraries for data augmentation, but ultimately you have to do it. It doesn't do data augmentation by itself. Okay.
Okay. Are there any AWS services which, yeah, you want?
See, data augmentation is an idea, isn't it? Right? Right. So it's not going to give you new data for like existing data. So if you give a cat picture, Amazon SageMaker is not going to give you like a dog picture. That doesn't make any sense. Correct? So for a cat picture, you want to do data augmentation. What you need to do? You should change the pixel slightly or the orientation slightly, or you flip it, you do all of that, right? That you have to do it by itself. All of those features, Amazon SageMaker will give you. Okay. But actually just throwing cat picture and asking for a dog picture, that's not the right thing to do. You get my point? Yeah? I hope that makes sense. Yeah?
Definitely.
All right. Okay. So yeah, so I guess we'll wrap up the session, guys. So thanks a lot for joining the session. Like I said, this will be listed on YouTube for further reference, and I'll put this Python notebook in a GitHub repo and link it, so you can refer this. You can run this. If you face any issues, let me know. All right. Thank you. Thank you.
Yeah, thanks.
Krishna, for your time.
Thank you. Have a great
Thank
day.
you, guys. Bye. Bye. Bye.